Voice is
sir.
clear to all? Yeah.
Yes, sir.
So my screen is visible?
Yes, sir.
Yeah, thank you. Okay. So very good evening to all. Today I'm going to give the uh, how to prepare the GATE exam. So my subject is network analysis. So today I will discuss what are the important topics, how we grab the GATE from this subject, network analysis. Okay. So for the GATE point of view, the main concepts in network analysis is so network elements and ideal voltage source, current source, and dependent sources, and mesh analysis, nodal analysis, KCL, KVL, and these are the main important theorems: Thevenin's, Norton's, superposition, and maximum power transfer theorem. And next is the transient response for AC and DC networks, and sinusoidal steady state analysis, resonance, two port networks, balanced three phase AC circuits, star to delta transformation, and complex power and power factor in AC circuits. Okay, so before going to start the syllabus, let us know what is the importance of the network analysis in a gate. Okay, I'll show you. So every year, is it my screen is visible?
Yes,
Yes. Yeah. So see here. So from the gate 2014 onwards, so in every subject they will. So see here. So in electrical circuits, average they are giving 14.50 marks out of 100. 14.5 marks they are giving in electrical circuit analysis, and remaining subjects they are giving 7%, 19% like that. So minimum we are getting 10 marks in each year from network analysis. That is network analysis, or is also called electrical circuits also. Okay, don't worry. In electronic point of view they are saying that network analysis. In electrical point of view we are calling electrical circuits. So syllabus is same for both electrical and electronics engineering. Okay, so see here from 2013 to 2016, in electrical fields and electrical circuits, this is the combination of circuits and electromagnetic fields. So in 2013 they are giving 11 marks, 14 10, and 15 14, and 16 17 marks. So this gradually increasing the percentage of the marks. Okay, so in gate 2015 to 18, so electrical circuits and electrical circuits, so 2019 10 marks, 18 15 marks. So that is the importance of this subject. So the basic is very very important. So after that this can be useful for so many applications in control systems. You go for in analog electronic circuits, electronic circuit analysis also we are using same concepts. Okay, so in gate 2020, so they given in electrical circuits. So see here, network theory, they given 10 marks. Okay, they given 10 marks from the network analysis. Okay, so what are the concepts in electrical circuits is nothing but network of ideal current and voltage source, Thevenin's theorem, Norton's theorem, and transient response, all those things. So let us discuss today. I will discuss on some gate previous questions on KVL, KCL, mesh and nodal analysis, and transient response. Is it okay? Shall I start?
okay, sir.
Yeah. See here. So this is some basic question. So generally, so in gate point of view, they will give 1 marks question and 2 marks question. So how much time it will take to complete the problem means. So generally, from the gate point of view, how they are giving the questions is nothing but 70% is the problematic. So that suppose it will take more than 1 minute. 30% is direct questions. The time taken to answer the direct questions is less than 1 minute. That is, it will take 30 seconds or 40 seconds. That is enough to solve the direct questions. So while preparing for the gate exam, we need to more practice on direct bits. So why? we need to more practice means we are suppose they will give direct bit and problematic bit means we will consuming same timing, yes or no? So from the direct bit also you are consuming 1 minute time, and problematic also you are consuming more than 1 minute. So we have to maintain the time while solving the question. This is very very important. Suppose you are solving the problem means it will take more than 1 minute. While solving the direct bit, we have to maintain 30 seconds, 40 seconds is enough to solve that question. Then only we can we can consume we can utilize the time to problematic questions. So that is time sharing is very very important while practicing or while solving the problems. So that is the one important thing. So in network analysis, so most of the questions from the problems only. Okay, that is logical way and some theoretical way also. Okay, so we know that what are the basic things of KVL, KCL, and mesh and nodal analysis. Yes or no? What is KVL? KVL states that, anyone? What
Entering
is
current
KVL? Okay, so generally we are expanding. KVL is nothing but Kirchhoff voltage law, Kirchhoff current law. So without KVL, KCL, we can't solve this mesh and nodal analysis. Yes or no? So, okay. So KVL is nothing but a algebraic sum of the voltages in the loop equal to 0 that can be used for the mesh analysis. KCL is nothing but sum of entering currents into the node equal to sum of currents leaving from the node. So that can be used for the nodal analysis. So these basic things are very very important while solving these type of questions. So see here, so this is the gate 2003 three paper question. The minimum number of equations required to analyze the circuit shown in figure. Okay, the minimum number of equations required to analyze the circuit shown in figure. So generally this problem is looking like, so how many number of minimum equations required to solve the question. So generally we are using two methods: mesh analysis, nodal analysis. Okay, 1 minute. Okay, you can use mesh analysis and nodal analysis. So can you observe how many loops are there here? How many loops are there? The
5.
number of loops is yeah, one. So see here, this is one, two, three, and this one is also four. Yes or no? One, two. These are the same thing. I will show you. Yeah. So see here. So actually this is like that. So this is one. Let us take this is the what? I1, and this one is I2, and this one is I3, and this is another loop is also there. This is nothing but we call as a I4. Okay, how many mesh equations needed? The number of mesh equations is nothing but a number of loops. So while solving by using the mesh analysis, we need to take four equations. We required four equations for mesh analysis. If we go for the nodal analysis, how many nodes are there here? Let us take this is the one, and this one is the two, and this one is the three, and this one is the four. Okay, and last one is the reference node. How many nodal equations is there here? Anyone? To solve this problem using nodal analysis, how many nodal equations is there?
5.
How many nodal equations? Generally, what is the formula for nodal equations? N minus 1. That means we need four equations. So you go for the mesh analysis also 4, nodal analysis also 4. But the question is here, the minimum number of equations required to analyze the circuit as shown in figure. So what is the minimum number of equations? So if you go for the nodal analysis, so what is the value of V1? Anyone tell me? What is the value of V1? What is the value of V1? See here. So value of V1 is nothing but a V1 is nothing but a V. Yes or no? So the
Yes, sir.
independent voltage source is equal to node voltage. So is there any equations required at the node 1? Yes or no? Using the nodal analysis, is there any equations required at the node 1? No need. Why? Because this node voltage is equal to branch voltage. The voltage between main node to reference node is nothing but this voltage. So already this voltage is directly they given. So how many minimum number of equations required to solve this problem? How many minimum number of equations required?
Four, sir.
Is it 4? Is it okay? Already they given V1 equal to V value. No need to apply KCL at this point. We need to apply 2, 3, 4. So these three equations is enough. No need of this nodal voltage equation. Why? Because this node voltage is equal to V. So how many minimum number of equations required to solve this question? How many number of minimum equations? Yes or no? So 2, 3, 4. So we need how many equations? 3 equations is enough to solve this problem. So now what is the answer for this question?
Three, sir.
Anyone? 3. So minimum number of equations required to analyze the circuit. Already this V1 we know the value. So just we need to apply KCL at node 2, node 3, node 4. We can get the solution for this circuit. So that's why how many minimum number of equations? 3 equations. Okay. So this is the basic problem. So we know how many number of equations required for nodal analysis, mesh analysis. Can anyone tell me number of loop equations formula? Can anyone tell me number of loop equations formula in terms of branches and nodes? Anyone? B minus B minus of n minus 1. This is the number of loop equations formula. You can write directly like that. B minus n plus 1. So this is the number of loop equations. Number of nodal equations. What is the formula for number of nodal equations? N minus 1. Is it clear? Is it
Yes, sir.
clear? Yeah. So this is the one type of problem, basic problem. So okay. So next one. So see here. So this is some logical question. So already we know how to reduce the given network. So we having number of resistances. We are using some star to delta conversion technique. We can find the equivalent resistance of the given network. Yes or no? So see here, we having 12 1 ohm resistances are used to form a cube. 12 1 ohm resistances are used to form a cube. The resistance between two diagonally opposite corners of the cube is okay. So we having one cube. So the cube having a 12 branches. Each branch having how much resistance? Each branch having how much resistance? 1 ohm. We need to find the resistance between diagonally opposite corners of the cube. So just shall I try to draw this cube? See here. So cube having how many branches? Cube having how many branches? So 12 branches. So this is the cube. So the each branch of the cube is how much ohms? Each
One
branch of
more.
the cube is 1 ohm. So let us take this is the one diagonal point is the A, and another diagonal point is the B. I need to find the equivalent resistance between these two diagonal points. Equivalent resistance between two diagonal, that is resistance between A and B. Let us take resistance between A and B is the R equivalent. Okay. Let us assume the voltage across the A and B is V input voltage. I am taking V in. So see here, this is very simple. I need to find the equivalent resistance between A and B. Okay. So let us assume the current flowing through point node A is I. Okay. So all the branches having equal resistance or unequal resistances? Anyone?
Equal risk.
All equal resistance. equal resistances. Let us take all the 1 ohm. It carries the current I. It can be divided into how many branches? Is current divided into how many branches? This current flow through 3 branches. Yes or no? This current flows through 3 branches. What is the each branch current? Anyone? What is the each branch current? All the branches having same resistances. See here, it will be whatever the current I am flowing through this I, it will be split up into a 3. Suppose it will be divided into 2 means, what is the each branch current? Both are same resistances. What is the each branch current? Generally, I by 2, I by 2. Yes or no? Suppose it will be divided into 3 branches, each branch having same resistance. What is the each branch value? Each branch
I
current
by
value? I by 3. Okay. So it will carry same current, yes or no? So this is the what? I by 3. And this is also I by 3. And this is also what? I by 3. Is it clear or any doubt? Now, this branch subdivided into how many parts here at this node? At this node, it will be divided into how many parts? 2. Yes or no? Yes or no? This I by 3, it will be again divided into 2 parts. What is the each branch current now? Anyone tell me what is the each branch current? I
I
by 6. Why I by 6? This I by 3 divided into 2 subparts. I by 3 by 2. It is I by 6, it is also I by 6. Now, this I by 3 also divided into 2 parts. What is the value of this value? What is this value, anyone? It is also I by 6. Yes or no? I by 3, it is again divided into 2 parts means I by 6. So what is this current value? Anyone tell me what is this branch current? What is this branch current? So apply KCL at this point. Sum of entering currents equal to sum of leaving currents. So it getting current I by 6. It is also getting I by 6. What is this value now? Anyone? What is this value?
I by 3.
I by 3. So why I am taking this branch currents means, so the total resistance is nothing but a input voltage by input current. Yes or no? Yes or no? The input resistance, the equivalent resistance is nothing but whatever the current leaving from that branch means total voltage. So that's why I am finding these branch currents. So now apply KVL at this loop. Apply KVL at this loop. This is one loop or not? Yes or no? So whatever the current is leaving from, it will meeting these 3 branches and come to negative portion. Yes or no? So see here. So each branch having same resistance. Let us assuming R. Instead of 1 ohm, I am taking R. Now, so apply KVL here. What is the KVL states? KVL states what? Algebraic sum of the voltages in the loop equal to 0. Otherwise, sum of sources equal to sum of drops. So we can take like that also. Don't worry. So here we having only one source. What is that voltage value? What is that voltage value? V in is equal to. So what is the voltage drop here? The current flowing through this branch into resistance. Yes or no? I am taking I by 3 into R. I by 3 into R plus, what is this branch drop? So this current will be flowing through like that. What is this branch? I by 6 into R plus, what is this drop? I by 3 into R. Is it clear or any doubts? Is it clear? Is it okay to all? Now, which is the common point here? Which is the common point? I is the common. I am taking V by I is equal to, they clearly given, what is the R value? What is the given each branch resistance value? How much? 1 mho. Yes or no? So this value becomes 1 by 3 plus 1 by 6 plus 1 by 3. How much this value? How much this value? 6. So this is 2 plus 1 plus 2. So what is this value now? 5 by 6 ohms. Voltage by current is nothing but a total resistance. So the equivalent resistance between A and B is 5 by 6 ohms. Answer is A. Is it okay or any doubts? So to solve these type of problems, we need to assume one cube. So we need to apply the KVL at first loop only. Then only we can get the equivalent resistance between A and B. Okay. Is it okay? Is it okay? Shall I go to next problem?
Okay, sir.
Yeah. Next
Sir,
one. Yeah. Tell me.
sir, a problem ఇంకోసారి explain చేయండి సార్.
See here. First of all, they given what? 12 1 ohm resistances are used to form a cube. So first of all, I need to know what is cube here. So I'm writing the cube. Otherwise, I will show you. Is it okay? This cube is okay.
Okay, sir.
So the resistance between two diagonally opposite corners of the cube is, so this is the cube. So A and B is the two diagonal points. Yes or no? A and B is the two diagonal points. I need to find the equivalent resistance between A and B. Okay. So I'm writing the two terminals A and B. The voltage across the A and B is the V in. The current through the node A is I. Okay. Whatever the current is entering into this node, it can be divided into how many parts?
Three parts.
Three parts. So each branch having same resistance or any some other resistance.
Same
All are
resistance.
branches having same resistance, 1 ohm. So let us assuming R. So what is the each branch current now? What is the
I
each
by
branch current? I by 3, I by 3, I by 3. Is it clear? Now,
uh,
whatever the I by 3 current is flowing, again it will be divided into how many parts here?
two parts.
How many? Two parts. So each branch current is I by 6, I by 6.
By six.
Okay. So here
Yes, sir.
also this whatever the current is carrying I by 3, it is also subdivided into two parts. So this is I by 6 or this is also I by 6. Okay. Now, what is this branch current? What is this branch current? So here I by 6 is coming to this point. I by 6 also is coming to this point. So sum of entering currents equal to sum of leaving currents. So what is this
Yes,
value now?
I
What is
by
this value? I by 3. I by 3. I by 6
three.
plus I by 6 is I by 3.
Okay.
Okay. So now
Okay, sir.
find the voltage by current ratio. Voltage by supply voltage by supply current is nothing but equivalent resistance. Is it
Yes, sir.
okay? Okay.
Yes,
So
sir.
now applying KVL at this loop. Now I am applying KVL at this loop. What is KVL states that sum of sources equal to sum of drops. Other the algebraic sum of the voltages in the loop equal to 0.
Zero.
Okay. So V in is equal to what is the drop here? The current flowing through that branch
I by
into
three.
the
Current
current flow
into.
I by 3 into R. Okay.
Uh,
Now this current is again moving to this branch. What is this branch voltage drop? I by 6 into R. Yes or no? I by
yes.
6 into R. Then it will be moving like that. What is this branch drop? I by 3 into
I by
R. R. So they given clearly R value is how much? R value is
one
1
ohm.
ohm. So as I'm commenting this I point, V by I equal to what is the value? 1 by 3 plus 1 by 6 plus 1 by 3. So the LCM
Yes.
is the 6. We can get the what is the value? 5 by
Five
6.
by six.
So while doing this practice, we can do this problem in within 1 minute. Don't worry. Okay.
Um,
So generally they will
okay,
give this
sir.
type of problem. So we need to analyze the circuit first thing. So what they are given, what we need to find. Is it okay?
Okay, sir. Okay, sir. Thank you, sir.
So see here, this is the bridge type of problems. So they given bridge resistances values. What is the R1, R2, R4 is equal to R and R3 equal to 1.1 R in the bridge circuit shown in figure. The reading in the ideal voltmeter connected between the A and B is. So I need to find what is the voltage between A and B. What is the voltage between A and B point? Let us take this is the VA and this is the VB. So let us assuming 10 volts it will supply the current is I. So this I will be divided into two currents. Yes or no? What is this value? Let us assuming I2. Let us assuming I1. Can anyone tell me what is the current through the R2? R1, R2, R. What is the relation between R1, R2? So there is only ideal voltage source. Ideal voltage source having no resistance. It will be like a open circuit. So this is very important. Ideal voltage source having no resistance, no series resistance. Whatever the current is flowing, same current is also flowing to R2 also. So how they are connected? How they are connected? R1, R2 are connected in
Series.
series. Is
Series.
it clear? These are two in series, and these two are also series.
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 Yes or no? So I need to find the VA and VB. VA and VB. So this is the reference node. Obviously, this is the which node? This is the reference node. And this is the zeroth node. Okay. So what is the voltage VA point to reference point? R1, R2 are series. I will show the circuit here. It will your circuit should be like that. One resistance, another resistance, this is resistance. The A point and this is the B point. What is the total voltage they given? How much voltage they are given? 10 volts. So this is how much
10
ohm?
volts.
What is this value? 1 ohm. R1 is 1 ohm. R2 is 1 ohm. R3 is how much? So this is 1 ohm. This is 1.1 ohm. Yes or no? R1, R2, R4, R3.
1 meter.
Okay. So anyone tell me what is the voltage divider rule? What is voltage divider rule? Voltage divider rule states that the branch voltage equal to total voltage into that resistance
Output
by
voltage
total
by
resistance.
amount.
Sir, no? VA equal to total voltage VT into what is branch resistance? What is this branch resistance? So let us take I am writing this like R2 by
2 ohms.
R1
2
plus
ohms.
R2.
2 ohms
Is
అంటాను.
it clear? The voltage divider rule states that the total voltage into that branch resistance by total resistance. Similarly, can you tell me what is the VB formula? VB formula. This is the VB point. VB equal to what? Total voltage into what is the that branch resistance? Let us assuming this is the R3. R3 by
3 by
R3 plus R4. R3 plus
R4.
R4. So, okay, we know the total voltage. We know the R1, R2, R3 and R4. Just find the VA and VB. So what is the voltage drop between VA and VB formula? Anyone? VA minus VB. Yes or no? They are asking the voltage between the A and B. So A and B is nothing but VA minus VB. Okay. So just find the VA value first. What is the VA value? Total voltage is the 10 into what is the resistance value? 1 divided by 1 plus 1 is 2. So what is the VA value? 10 into 1 by 2. Yes, no, R2 is the 1, 1 plus 1 is the 2. We can get the how much voltage?
5, sir.
It is 5 volts. Is it 5 volts? Yes or no? What is VB?
5.
VB. Total voltage into what is the R3 value?
1.
1.1 by, so 1.1 plus 1, 2.1. Okay, we can get this value around, this is 10 into 11, 110 by 21. Can anyone tell me what is this value? 110 by 21, it is around 5.238. Please check it using calculator. We can get this value is 5.238. So this is the VB value. So what is the VA minus VB now? 5 minus 5.238. We can get the, what is the value? What is the value? 5.238. 5 minus 5.238
Minus 0.23.
minus 0.238. Okay. So this is the answer for this question. Is it okay? Just simple thing is, once you know the voltage divider rule, we can directly get this value. So directly substitute. So 10 is the common, VT is the common. Just substitute R1, R2, R1, R2, R3, R4 values here. We can get direct value. This is okay. So we can take less than 1 minute only. Okay. So for explanation, I will giving all those things. So while doing the practice means we can do this problem within 1 minute. Is it okay?
Okay, sir.
Okay. So shall I go to next problem? Okay. So see here, a 2 millihenry inductor with some initial current can be represented as shown in below, where S is the Laplace transform variable. The value of initial current is okay. So this is in terms of we have to know Laplace equivalent formulas. Already we know that Laplace equivalent formula for inductance and voltages. Yes or no? Yes or no? So see here, I need to find the what is the initial current through the inductor. So what is the initial current formula? Anyone? Initial current is nothing but I of 0. So I need to find the initial current through the inductor. So they clearly given 2 millihenry inductor. It having a value is 0.002 s. I need to find what is I of 0. So before going to this, so I need to find. Can anyone tell me what is the voltage across the inductor formula? What is the voltage across inductor formula? V of t equal to
L in,
L
L
into
L
di of t by
T
dt.
T.
Yeah. So I'm applying Laplace transforms on both sides. We can get what is the equation now. So t domain converted into frequency domain.
Yeah.
V of s equal to L into
To
what is
S
di
into
of t by dt?
S into I of S.
S into
I of
I
S.
of s minus I of 0 also there. Okay.
Yes, sir.
So generally we are neglecting this value, but they clearly mention I need to find the what is the initial current through the inductor. Okay, by using this final value theorem, we can get S into f of s minus f of 0. Okay, S into I of s minus I of 0. Is this formula is clear? Is this
Yes,
formula
sir.
is clear? Yeah. Now let us assuming V of t applying for this circuit. V of t is applying for this circuit. Let us assume V of t equivalent is equivalent Laplace is what? V of s. Yes or no? So all are in S domain. I need to convert this t domain into S domain. V of t is nothing but V of s. Okay. Can apply KVL in this loop. What is the formula now? Apply KVL. Apply KVL in this loop. So what is the formula now? V of s. Yes or no? V of s. So this is the plus and this is the source. So all are both are in same direction. So what is the value? Vs plus 1 millivolt is equal to 0.002 S into I of S. Just simply I am applying KVL here. Okay, why I am taking plus here, anyone? So whatever the source, this is also source, both are in same direction. The current is in same direction means we need to add the sources. The current is opposite means we need to subtract the sources. Is it clear? Plus minus both are in opposite direction, current is in same direction. Okay, plus minus. Here also current is leaving, here also current is leaving. That's why V of S plus 1 millivolt equal to 0.002 S into I of S. Is it clear or any doubt? Applying KVL. Okay, now V of S equal to 0.002 S into I of S. So this 1 millivolt become what? Minus 1 millivolt. Okay, so see here, these two equations are in same or not? Both the two equations are in V of S equal to Ls into I of S minus L into I of 0. So this is also Ls into I of S minus I of 0. Yes or no? Both are in same or not? Just compare these two equations. So what is this value? What is this value? L into I of 0 is equal to what? 1 milli. Yes or no? L into I of 0 equal to 1 milli. Then I of 0 equal to what? I of 0 equal to 1 milli. What is the L value? What is the L value they given?
2 milli.
2 milli. So what is this value now? What is this value? 1 by 2 is nothing but 0.5 amps. Is there any doubts? Just I am writing one equation. This equation should be, it should be in the form of V of S equal to Ls into I of S minus L of I of 0. L into I of 0. Just L into I of 0 equal to 1 milli. Then I of 0 equal to 1 milli by L. This is 0.5 amps. Is it okay? Is it okay?
Yes, sir.
Yeah. So this is a simple thing. So once you know the equivalent Laplace equation, we can compare this equation with respect to uh, conventional equation. We can get this I of 0 value. Okay. So this is on another type of problem. A fully charged mobile phone with a 12 volts battery is good for a 10 minutes talk time. Okay. So a fully charged mobile phone with a 12 volts battery is good for a 10 minutes talk time. Assume that during the talk time, the battery delivers a constant current, that is 2 amps, and its voltage drops linearly from 12 volts to 12 volts to 10 volts. As shown in figure, how much energy does the battery deliver during this talk time? So see here. So a fully charged battery, what is the good for 10 minutes talk time? So this can be used for 10 minutes talk time. So while talking in the talking through the phone, this voltage it will be drops from 12 volts to 10 volts. The current is constant. What is the current value they given? The current is 2 amps. Okay. How much energy does the battery deliver during this talk time? Okay. So what is the formula for energy? Anyone? What is the formula for energy? Energy in terms of power. Anyone? What is the formula for energy? Energy we are indicating E or W. E equal to integral P of t dt. Yes or no? The integration of the power is nothing but a energy. So that is 0 to t. What is the formula for P of t? Power. Power formula.
I
Anyone?
have I swear VF.
I square r of V of t into
I have to.
I of t. Okay. So they clearly mention the voltage, it will be changes from 12 volts to 10 volts during the talk time. But current is what? But current is what? The current is delivered constant. Okay. Voltage it will be changes, but current is constant. Just substitute voltage and current in P of t. We can get energy equal to E equal to integral 0. So they given here time in minutes. Just convert into seconds. So 10 minutes means how many seconds? Anyone? 10 into 60 seconds. We can get how much?
600.
600. 600 seconds. So V of t. So I don't know. Just I am taking V of t. And I of t is the what? I of t is the constant. That is 2 into dt. Okay. Now I am writing this 2 integral 0 to 600 V of t dt. So integration of the voltage. So generally we call as this is nothing but a area. This is nothing but we call as a what? Area. Integration of this portion is nothing but we call as a area. So see here, observe here. So this is 10 volts from 0 to 10 minutes. Is constant or variable? It is looking like what? The shape is looking like a what? The shape is looking like a rectangle. Yes or no? So the area of the rectangle up to 10 volts. So this is the area of this voltage. And what about this portion? It is looking like a what? This portion.
Right angle.
This is a
Right
right angle triangle. Right angle triangle. Now, so I am writing this 0 to t into V of t is nothing but area covered over the 0 to 10 minutes. So here two areas will be there. One area is the what? One area is the what? So this one is the triangle. That means triangle. Another one is the what is this? This one
rectangle.
rectangle. So 2 into area of rectangle and area of plus area of triangle. Okay. 2 into area of rectangle plus area of triangle. So what is the rectangle area formula now? 2 into area of rectangle. Anyone?
L into
10 into
L
10
into
into
this.
how much? 10 into 600. 10 into 600. This is the length and breadth. Plus what is this area formula? Anyone? Area of triangle formula half into
Into L into B.
uh, height into breadth. What is the height value here? What is this value?
2,
What
sir.
is this? 2 into, and this one is 600. So this 2 is cancelled. So this is 6000 plus 600. Yes or no? 6000 plus 600, how much? 6600. And again it will multiply into 13200. So it is how much? 1.32 kilo. What is the units for energy? 13.2 or 1.32? Sorry, 132,000. That is nothing but 13.2 kilojoules. Sorry, 13200. That is nothing but 13.2 kilojoules. Okay, is it okay?
Okay, sir.
Okay, so see here, integration of the any voltage is nothing but area. Okay, the area is nothing but a integration of that voltage. Okay, this is another type of problem. So what is this question? In the interconnection of ideal sources shown in figure. What is ideal sources means? Anyone? What is ideal sources means? Ideal sources having doesn't having any
Resistance.
internal resistances. Okay, resistance is zero. Is shown in figure. So 60 volt source is absorbs power. Which of the following can be the value of the current source is I. Okay, so this one thing is absorbing. What is the difference between absorbing and delivering? Suppose we having one source, it delivering power means having a voltage source. It delivering power means what is the direction of the current? Current is leaving from the positive or current is entering into the positive?
Ladies.
Well, current is delivered. What? Current is leaving from the positive. It is the delivered case. Suppose current is absorbing. So clearly mentioned 60 volt source is absorbing the power. What is the direction of the current? What is the direction of the current? Absorbing power means current is entering into the positive. So these two things is very very important. This voltage source is supplying the power. This voltage source is consuming the power means receiving the power, that means absorbing the power. Okay, so they given some different current directions, so he need to take what is the current direction here, current into the plus or leaving from the plus, current is entering into the plus or leaving from the plus. My question is clear. Here 60 volt source is absorbing the power. What is the direction of the current here? Current is entering into the 60, current entering into the positive or leaving from the positive? Yes. What is the direction of the current? Is there any doubts? So two things. While source is absorbing the power means current is entering. So this thing we have to know to solve this problem. So let us take here source is absorbing the power. Let us take it, current is entering into the source. Let us take this is the IS. This is the IS. Now what is the current here? What is the current here? Anyone? What is the current leaving from this 20 volts? So these two are in connected in series or not? These two are connected in series or not? How much current it is
Yes,
leaving?
sir.
How much current? 12 amps. So is this current is also leaving I. So I need to find the I value. So just apply nodal analysis here at this node. What is the node current equation? Sum of entering currents equal to sum of leaving current. That is, so 12 is entering, 12 equal to
I plus.
I plus IS. Is it clear? What is I now? I equal to
12
what?
minus IS.
IS. Okay. So this is data not sufficient problem, but we can solve this problem using these options. Whatever you are calculating the current, it should be less than 12 or more than 12. Whatever you are calculating the current I, it should be less than 12 or more than 12. Obviously what? So
Less than.
IS is some positive value. They clearly mention it absorbs the current. I don't know what is the IS value, but whatever you are calculating the current, it should be less than 12. So just compare this question with the answers. So this is the 10 amp. It should be less than 12. Remaining all are what? 13 amps is more than 12. 15 and 18 is also more than 12. So which is the correct answer for this question? Yes. What is the correct answer for this question?
Tens.
10. Okay. Just by comparing this equation with the options. So while substituting this value here, it doesn't suitable for this all. Why? Because the whatever we are substituting this, it should be less than 12. So it is obviously 10 amps. So this is the answer for this question. Okay. Is it okay?
Yes, sir.
So next one. So the circuit shown the power supplied by the voltage source is. So what we need to calculate here? What we need to calculate here?
Powers.
Whatever the power supplied from the source. So they clearly given 10 volt source. I need to find what is the current supplied by the source. So once you know this current, what is the formula for power? What is the formula for power?
V into
10 into I. Yes or no? 10 into I. So I need to calculate I here. How to calculate? Okay. So to calculate the I value, just let us assuming. So here in this node, 1 amp is entering and 2 amp is entering. What is the leaving current here? What is the leaving current? Apply KCL at this node. 1 amp is entering, 2 amp is entering. What is the leaving current? What? How much?
3 amps.
Is obviously how much? 3 amps. Is it okay? So what is this current now? Apply
I1
KCL at this
plus
node. What is this
3
current?
amps.
I plus 3. Okay. So these two are in series. Obviously, these two are in series. So let us assuming this node voltage is V1. I'll tell you later why I'm assuming V1 here. Can anyone tell me what is this node voltage? What is this node voltage? What? What is the
Tens.
voltage at this node? 10 volts.
10.
Yes or no? This is ideal voltage between main node and reference node. That node voltage is nothing but a branch voltage. This is the 10 volts. So I need to find the I. Just apply KCL at this node. I need to find the I value. Just apply KCL at this node. So can you apply KCL at this node? What is the formula now? V1 minus 10 by 2. Is it clear? V1
Yes.
minus 10 by 2. Yes or no? I'm writing this here. V1 minus 10 by 2. So this is one node. What? So sum of entering currents equal to sum of. What about this node? This node. So this is obviously which node? Reference node. Yes or no? This
Yes,
is
sir.
reference node plus V1 by 2. So these two are leaving and this is also leaving plus 1 equal to 0. Is there any doubt? V1 minus 10 by 2. So this current is leaving from this node. This is also leaving. This is also leaving. So sum of leaving currents is equal to 0. That is nothing but a KCL. Now we can easily calculate what? Now you can easily calculate the V1 value. What is the V1 value? V1 by 2 minus 5 plus V1 by 2 plus 1 equal to 0. So V1 by 2 plus V1 by 2 is nothing but a V1. V1 equal to what? V1 equal
4.
to what?
4.
4 volts. So now you know the V1 value is the 4 volts. So what is I plus 3 now? What is the formula for I plus 3? I plus the branch current I plus 3 equal to what is the value? 10 by 10 by 10 minus 4. Yes or no? Yes or no? I plus 3 equal to V 10 minus 4. Branch current is nothing but 10 minus 4 by 10 minus 4 by 2 is equal to I plus 3. Is there any doubt?
No.
10 minus VA minus VB by 2 equal to I plus 3. So what is this value? 3. So I plus 3 equal to 3. Then what is the value of I? I plus 3 equal to 3. What is the value of I? I 0. So current is 0 means what is the power?
Zero.
0. 0 watts. So that is the answer. Is it clear or any doubt? Just I need to calculate this I plus 3 value. I am applying nodal analysis. I am calculating V1. Once you know the V1, what is this branch current formula? The branch current direction is this direction. That's why I am taking 10 minus 4 by 2 is equal to I plus 3. Is equal to I plus 3. Then we can get the I value is 0. Then what is the power? Power is what? Power is what? 0 watts. Okay. So go for the next problem. See here in the following figure,
Sir, the voice is not audible, sir.
Good evening to all. Sorry for the interruption. Now my voice is clear.
Yes, sir.
Yeah. Now screen is visible.
Yes, sir.
Is it visible to us?
Yes, sir.
Yeah. Once again, I am repeating. So see here.